Hello friends, this video on application of derivatives part 24 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 23. Let's learn absolute maxima and minima. As I told earlier, absolute maxima and minima is defined in the closed interval where we know what is our domain. And in this case, the critical points are, one is my endpoints. These things I discussed earlier, I'll discuss once again. Then the turning points. And then non-differentiable points. Non-differentiable points. So I'll take an example. For example, you have this kind of function, right? So in this case, my maxima and minima are the turning points. If you see this guy, this guy, this guy. So we'll talk about a turning point. There are scenarios where the function is like this, monotonic function, where we don't have turning points. There the maxima and minima are endpoints. These endpoints in this case, turning point in this case. They have functions which are non-differentiable. For example, this function. So here if you see this function is non-differentiable at this point. So you can have maxima and minima at this point also. Correct? So absolute maxima and minima can have at 3 points. So we'll define a rule or steps how to find absolute maximum minima, where we'll find endpoints, turning points or non-differentiable points, and then we'll try to find the exact value of absolute maxima and minima. So in this case, the absolute maxima is this guy actually, not this guy. So what we do is we find all the points, all the critical points actually. These are all critical points. For graph, all critical. For example, I'll tell you, my graph is something like this. Let's suppose start from here. Okay, this guy, something like this. I have a minima also. Then I have a non-differentiable point also, and then I have a maxima. Somewhere it stops here. So the points we should cover here are these points also, extreme points, non-differentiable points, all the local maximum minima, that is all the turning points. These are non-different points, and this, let's suppose this is also non-different point. So we'll consider all these points. All these points we'll consider, and then we'll find the actual value of all these points, and then whatever is the maximum is the absolute maximum, because that is 100% sure maximum in that particular domain. So that's how we'll do it. We'll take some examples, but just understand that here also the critical points are endpoints, turning points, and non-differential point. The only extra addition is the endpoint, because now we know which is the starting point and which is the end point, because it's a closed interval. So there is a theorem on this. It says that if my function is a continuous function on this closed interval, on this closed, I'll write to be specific, closed interval, then f will have an absolute maxima. If it attains, at least once, it will have absolute minimum and absolute maximum. So this is the closed interval, it will have at least once minimum and maximum. So if f is a differentiable function on the closed interval and c be any point on this, then f dash c is equal to 0 if it attains a local maxima, and f dash c is also 0 if it attains the local minima. So if it is a differentiable function, if you differentiate this guy, then that point is either maxima or minima, or sometimes point of inflection also. There is a rule to find maxima and minima, as I explained. We first find all the critical points. So critical points are nothing but f dash x is equal to 0, f is non-differentiable, or endpoints. Right? And take endpoints also. So those critical points I am saying is critical points, I include everything. That's the way I look into it. Critical points includes f dash x equals 0, the point where it is non-differentiable, and the end points. So I have all the points. Now at all these points I calculate the value of f. That is fc1, fc2, all the values are calculated. Correct? Now with this I'll identify what is the maximum, what is the minimum value. And the greatest value is the absolute maximum and the least value is the absolute minimum. See, graphically, but I'll explain you what is this. My graph is like this. It starts from here, let's suppose, right? There's a curve like this here. There's a curve like this here. This is a non-differentiable function here, non-differentiable point, and there's a maxima also. So what I do is I'll take all the points starting from this point where the turning points I'll take. This is a turning point, this is a non-differentiable point, non-differentiable point, the end points. I'll take all these points. At all these points I'll find the value, and then by observation I can find that this guy, if you see, is the minima and this guy is the maximum. So that is the approach, the crude approach. Because it's a closed interval, I know all the points, I can get all the points. In the earlier case when we were talking about local maxima and minima, the interval was not closed. But here the interval is closed because it starts from here and ends from here. So I have the luxury of finding the value of all the points and also the function value at these points. Correct? So we'll do that and find the maxima, and that guy is the absolute maxima and minima. We'll take some examples. We have to find the absolute maxima and minima for this function at this interval. So please note, whenever we talk about absolute maxima and minima, the interval has to be defined. It has to be a closed interval. So my fx is equal to x cube. So as I told, my points will be what? First thing is turning point, right here, and then it will be non-differentiable points and end points. Correct? So let's talk about turning point. For turning point, my f dash x has to be 0, or f dash x is nothing but 3x square has to be 0, or x is equal to 0. This is my first value I get from turning points. Non-differentiable, since it is a continuous function, it is differentiable. So I don't have any non-differentiable point. Then I'll take endpoints. Endpoints, x is equal to what? Minus 2 and 2. So my total points, my critical points I can say is, my critical points are nothing but minus 2, 0 and 2. Why? X is equal to minus 2, 0 and 2. I merged all this because I need to get turning points, non-differential points and end points. Turning point was 0, non-differential point, it doesn't exist, and end points what? Minus 2 and 0. Now I have to find f of all these points. So f of minus 2, if you see the first point if you take, is nothing but minus 2 cube, that is minus 2. Then second point you take f of 0. F of 0 is 0 cube, that is 0. Third is f of 2. F of 2 is nothing but 2 cube, that is 8. So if you see here, this guy is the minimum value and this guy is the maximum value. Just by observation. Thus I can say that this is the absolute maxima and this is the absolute minima. Correct? Got the approach? You have to first find the critical points. Once you have the critical points, you have to find the value of f at all these points, and then by observation we can find the maxima and minima. Let's take one more example. Find the maximum profit a company can make if the profit is of this function. Here also, since the profit is given, but cash here is this. Is this an absolute maximum in a question? No, it is not. Why? Because it is an open interval question. The interval is not closed. If you see, just by looking at the question, you can say the interval is not closed. So it's an open interval question. So here we are not talking about absolute maximum number. Here we are talking about local maximum number. Why? Because it is a open interval. I intentionally took this because I wanted to clear this doubt here, because this is a local maximum in your question. This is not an absolute maximum in your question. Here I have to find the maximum minimum profit. So for local maximum minima question, we can't have the end point because there is no end point. The only points we can consider is turning point and non-differentiable. But if you see, this guy is a continuous function, so non-differentiable is not in picture. So we can consider only the turning point, that is p dash x is equal to 0, can be the only points considered. Let's find p dash x. 41 becomes 0, 24x becomes minus 24x becomes minus 24, and 18x square becomes 18 into 2x, and this is equal to 0. So we solve this, my x is nothing but minus 24 by 36, that is minus 2 by 3. Now I have to find whether at this guy it is maxima or minima or inflection point. Correct? Because I know that x is equal to minus 3 is a critical point. It can be a maximum value, it can be a minimum value, but we don't know actually it is a maxima or minima. So what we do? We can use second derivative test. So let's find double dash x. This guy is nothing but my p dash x came out to be minus 24 minus 36x. So my p double dash x will be 0 minus 36, and my p double dash of 2 by 3 is minus 36, and this guy is less than 0. So I can say that minus 2 by 3 is point of maximum. Correct? But the question asking the point of maxima? No. The question is asking the maximum profit. So the maximum profit will be nothing but p of minus 2 by 3, and that is nothing but 41 minus 24x, that is 24 into minus 2 by 3 minus 18 into x square, that is minus 2 by 3 square. And if we solve this, we'll get 49 as the answer. And that is the maximum profit the company can make. Correct? Very simple. Here also we found the critical points. The critical point was minus 2 by 3, but we were not aware with whether the critical point is for maxima, minima, or for point of inflection. We found p double dash x, and we found that value is negative. That means p minus 2 by 3, 2 minus 2 by 3 is maximum. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.